Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a sample calculation for the first experiment with the do-it-yourself projectile launcher. The first experiment is flight time as a function of initial horizontal velocity. So, sounds complicated. It's not. Remember, y as a function of x. We're going to manipulate the initial horizontal velocity. That is, we're going to shoot this projectile from our little launcher, this guy right here, except it's going to be horizontal, and we're going to shoot it faster and faster and faster. So we're going to manipulate the launch velocity and see how the flight time is affected. I used to flick nickels. I have a marble gun in the classroom. This is sort of the really fancy version. This guy on the left obviously has no initial horizontal velocity. And this guy on the right does have an initial horizontal velocity. This demonstration gives away the answer to the lab, so I hesitate to show you this. But watch the video if you want to know the answer and not, struggle with statistical analysis. So what is this sample calculation? Well, I say follow the criteria presented in the lab report checklist. So here we go. Here's the lab report checklist, name and date, statement of purpose. I was kind of weak with my statement of purpose. I simply titled it Horizontally Launched Projectile, T versus VIX. So this is the mathematical symbolic way of saying time as a function of initial horizontal velocity. All right, y is a function of x. So then what? After you state your question or your purpose or your problem, you hand draw a diagram of the physical system or the apparatus. And in this case, it's just my little projectile launcher. This thing, clipboard, couple clips, rubber band, and the tag. Put it on the edge of a desk, and you're going to fire it horizontally. Then, after you draw the diagram, you want a hand-drawn symbolic and numerical statement of measurements and assumptions. So I don't have the numbers yet, but this is sort of like fill in the blank. How many seconds does it take from launch to impact? How far does it go? What's the change in horizontal position? So for this one, you got to drop a plumb line from the edge of the desk to the floor, and that defines the origin. And you got to measure this horizontal distance the projectile moves while it's in the air. It's called the range. And then the calculation is just range divided by flight time. That's the horizontal velocity, so meters per second. So I don't have any numerical data to actually put into these calculations, but that'll be the next video. Then we vary the initial horizontal velocity. So the sample calculation is supposed to be like a storyboard. It's supposed to walk you through the experiment. And this diagram is supposed to show slow, medium, fast, and then this table is supposed to emphasize do duplicate trials. You can have a slow, medium, and fast, a qualitative description, but make sure for each strength, measure the range, measure the time over and over again, average them. Now, I put velocity over here because it's a calculated value, but remember, it's our independent variable. So when we make our spreadsheet, we actually want it to the left of flight time. Usually in spreadsheets, you want X on the left and Y on the right. So not the greatest order for the columns here. And as usual, we make a prediction. So as we launch this thing faster and faster, as we move to the right on our graph, what's going to happen to the flight time? Is the flight time going to be in the air longer? Is it going to be in the air for a shorter period of time if we shoot it faster? Is it going to have no effect? Is it going to be a horizontal line? Is it going to be an exponential, inverse? We talk about all these functions. Make a functional prediction. And see you in the next video. Happy experimenting.